Going live.
Oh, I see that.
What's up, guys? Welcome to the Intellect Integration 4.0 Solutions weekly live stream. Today, we're going to be answering your questions on Industry 4.0, IIoT, and digital transformations. And we go live every week, so make sure you guys subscribe and turn on the bell notifications to get notified when we go live. Leave your questions down below. Both myself and Vaughn Turner will be monitoring the live stream chat. And we're gonna kick it over to Walker Reynolds, who's gonna be answering your questions. Walker, thanks.
Ahoy, thank you. All right, so good news today. I'm watching the chat. Normally I don't do that. Normally I got Zach and Vaughn, so I do have the chat over here. Number two, hey Vaughn, will you give Zach permission to record so we can get the meeting recorded before I say anything
That is done.
that he will want for posterity? All right, cool. How's everybody doing? So I'm in Dallas today. I'm in our office in Dallas, and I came back from New York over the weekend, and yesterday we got the first snow that we've had in like 8 years. So as I was driving through East Texas, it was snowing like huge flakes and stuff, and it stuck. And that's just not normal. And today in the Dallas Morning News, if you guys just want to know how ironic it is that we got snow, in the Dallas Morning News, there was actually an article telling us how to drive in the slush. You know, hey guys, I mean, that's how rare it is. Like the newspaper actually told us how to drive in the snow. So, but I'm in the office in Dallas today, and today I think we're going to cover 6-7 questions. I'm actually going to do a little commentary on OEE, also a little thing I sketched to kind of go over. But if you have any questions, we've pulled out stuff from the Discord server, and and then we'll answer anything that's in the chat that we can answer.
Real quick community updates. FrameWorks University, if you guys haven't heard, that launch is pushed back to next week on the 21st. And our mentorship call is this week. It's not too late to join mentorship. So I'll have a link below. Sign up now and join us for our call on the 14th. And
go ahead and send a shout out to everyone in the Discord server, please, to remind them that we're live right now. Yeah, and also the step one guys who are, I think the 9, is it 9, Vaughn, that are ready to do the practical?
Yes.
Practical is done. It just needs the final approval. It's like number 8 on the to-do list. So if I get through number 8 today, then it'll be disseminated today. But the delivery's been pushed back to the 21st. You'll have plenty of time to get through it. Enterprise mentorship, we're still working on, how we can do mentorship for an entire organization. So just like a single membership, but anybody who works for you can go through mentorship. And then one of the things we're going to do is we're going to go over Highbyte and the UNS Gateway. So there was a whole, you'll know in fact, I'll talk about UNS Gateway right now. So the UNS Gateway is a product that I developed like a year and a half ago, which was my entire goal was I wanted to be able to connect to any OPC UA server, and I wanted to be able to just take all the work that had been done in that OPC server and convert it to MQTT, any flavor that I wanted. So I wanted it to support Docker. So I wanted to be able to create multiple instances, and I could, select just certain spaces in the OPC server, that kind of thing if I wanted. And it was designed to speed up our integration. So it was designed, hey, we've already got this existing infrastructure with an OPC server that could be Kepware, top server, whatever. Or I've got many OPC servers, which is really common in a plant. You'll see like an OPC server in this area and one over in that area, and only this engineer knows about this one, and only that engineer knows about that one, and that kind of thing. And so what we wanted to do is centralize all that data. So the UNS Gateway didn't have a name; it was just a product that we developed, which we had a goal that we wanted to accomplish, which was we wanted to connect to an OPC server, and we wanted to be able to convert that to whatever flavor of MQTT we wanted and publish it into Unified Namespace. Now, people may ask the question, well, why wouldn't you use like the IoT gateway from Kepware, for example, if you're a Kep server guy? Well, the answer is that the IoT gateway doesn't do exactly what we want it to do. So in OPC terms, the IoT gateway is an object in the OPC server instance, and that object has variables underneath it. So in OPC speak, objects are the higher level objects in the OPC namespace, and the variables generally are your tags. Not always, but they're generally your tags. And you can grab any node object in OPC, and you can, using certain methods, you can browse the namespace underneath it. So like, say I have a node that is a specific channel in the OPC server, I can grab that channel, and then using the correct method, I can browse that channel, and then I can iteratively browse all the way down until I get to all my tags. So what we wanted to be able to do is just want to be able to connect to an endpoint, an OPC endpoint, and we want to be able to just convert everything in there to MQTT. There's no product out there that does that, right? Even Highbyte doesn't do that. Highbyte, you have to say which parts of the namespace you want to use in your models, right? There's not a mechanism to just go, hey, man, I want to make sure we grab that unified namespace question that just came in. Hey, I just want to grab everything and I want to publish it. Now, the reason why they don't do that in Kepware, the IoT gateway, you're limited in the IoT gateway in Kepware, you're limited to what you can publish. You basically, the way it's set up is you've got to go in, grab the tags you want to publish, drag them over, drag them into the IoT gateway, where do you want to send it? What's the broker? How often do you want to send it? That kind of thing. And then it'll publish in a JSON. And then on the other side, you need to parse that. Now, one of the beauties of the IoT gateway in Kepware is you can create a custom JSON structure. You can do that so that, say I've already got a parser that parses a type of JSON, you can just recreate that in the IoT gateway. But the IoT gateway doesn't do what we wanted to do, which was hit an OPC server, convert everything, and publish it over MQTT. Now, that's what the UNS Gateway does, and that's the only thing it does. The only thing it does is it connects to an OPC server, it converts the entire namespace, and it publishes it to a broker. It's only got 3 fields to configure. It's very slick, it's very fast, it's super lightweight. I suspect that the reason other people haven't done this is because they can't figure out how to make it run fast enough. That's what I suspect is the problem. Because I know that when I was writing the code, that was an issue I ran into. The trick, if you will, was, basically thread management was and not everyone's good at thread management in software development. And so, and at the end of the day, that was the issue. If you wanted to be able to pick up things fast enough, right? So what the UNS Gateway does is it hits an OPC server, converts the entire namespace, and publishes it over I can say I want to structure it Sparkplug A, and it basically takes the entire namespace. It doesn't send the difference between A and B. Sparkplug A and B is Sparkplug B has support for like UDTs and templates, right? Whereas Sparkplug A does not have that. Sparkplug A treats everything as if it's a tag, just a flat tag. So if I want to hit an A or B, or I want to do version 3.1.1 or version 4, version 5 of MQTT, I can do that. That's all it is. What we decided was, and now I don't want to minimize it. I mean, it was very difficult to write. And if you compare, one of the things we did during benchmarking was I took an OPC server and I pulled that OPC server every 1 second, every single tag. And then I did the same thing using the UNS Gateway. And it was like, 1/18th the payload. So when you looked over the course of like 1 hour, how much bandwidth did we use polling the OPC server versus using the UNS Gateway? It was 1/18th. Now, that part of that had to do with the types of tags we were polling and stuff like that, but they were exactly the same. It was literally the exact same name structure. It was the same OPC server. One difference was I had a OPC client pulling everything, and in the other instance, I had a UNS Gateway next to the server pushing everything to the broker. That was really the difference. And then we used the tool to sniff the wire, and it was just much, much, much more lightweight. I think the reason that all these gateways, like even if you look in the easy Easy Rack PLC by Easy Automation. They have an MQTT client in there, and you can send it flat MQTT, or you can send it Sparkplug B. You still have to select the tags that you want to publish, and you're limited to like 256 tags. So, and I suspect the reason that they do that is because they don't want to use the resources for all that scanning, right? So when everyone is building these gateways, it doesn't matter who they are. Everybody who's building some type of MQTT gateway there is no mechanism to just take an entire namespace, convert it, and publish it. And that's what the UNS Gateway does. Go ahead.
What would the use case for that be?
You have an existing infrastructure, right? I've spent millions and millions of dollars over the last 5 years implementing an OPC infrastructure. And then all of a sudden I'm ready to like go ahead and start putting everything in a data lake in the cloud. And then we're like,
do that over OPC. You want to do that over MQTT.
Correct. And so what happens is they'll try it, right? They'll try to publish everything, and it doesn't work. They hit, what's going on with our network? Why do we have so many instances of TPC exhaustion across all these nodes? And they start going through and they hit this critical mass, and they can't get everything to the data lake. They got data loss. They're losing integrity. They don't understand why it's not working. And so what we do is we just go in and basically put the UNS Gateway right next to the OPC server, convert everything, and then publish it up report by
second. You could have an enterprise that has 5 plants, and each 5 plants has OPC server. You'd want to connect those, but you're not doing any formatting during that connection.
No modeling, no nothing.
Right.
So that's the difference. So so that's the way that we kind of envision this working is, we had this discussion, right, about, what's the difference between UNS Gateway and Highbyte? Well, there's a huge difference between the two. UNS Gateway only does a really specific functionality, right? It serves a very specific purpose. Whereas Highbyte has many, many connectors. It talks to lots of things other than OPC. It does high level modeling. It does mid level modeling. It has multiple trigger events, so you can decide how you want to trigger an event inside of Highbyte. I mean, it has all these other features, right? Whereas the UNS Gateway is only designed to hit that server and convert everything into MQTT. Now, part of it's been tested with Docker, so you can spin up multiple instances of it. So instead of creating like in an IoT gateway, instead of going in and creating multiple connections, what we would do is create multiple instances in a container. So under the hood, there's a container for each connection, for each
connection to different brokers, connection to different OPC servers,
different servers, same servers. So let's say that what I wanted to do is I wanted to filter. One of the fields is a filter. Let's say I want to filter on a specific node in the OPC UA namespace, but the functionality is the same. Go to this node, take everything underneath it, and convert it to MQTT. Right, that's all that's going to happen, and I can filter down to a node. I have that ability, cool. So I could create multiple instances, right, in a container. Again, there's no overlap between Highbyte and UNS. We see it; they're going to work together. Right. In fact, what's most likely going to happen, the way we see it happening, is the UNS Gateway is going to connect to the OPC server and send everything into Highbyte for additional modeling. That's how we see it. But how concerned should one be about time synchronization of process data? That's part of the reason that you're using, that's part of the reason that you're using, MQTT is so let's say I on the process data, time synchronization. And the question, actually, it's a good question, and I'll answer it right now because it applies to what we're doing. Part of the reason that we use a tool like Highbyte, part of the reason we use Ignition Edge, part of the reason we use Factory Studio on the edge is one of the biggest challenges you have in machine learning, okay, is that for process control, the timestamp of a data point, that is when the value changed, okay, value and timestamp is unique to that sensor. Okay. So let's say I've got two values I'm monitoring. One is the pressure. One is the pressure of some water line, and the other one is the flow of that line. Okay, those sensors change at different intervals. Okay, and let's say I want to write a machine learning algorithm that's gonna find a relationship for every value X of pressure. What is my estimated value Y of flow? Right? Okay, that is a linear regression you might write in machine learning. One of the very first things that you have to do is, and people call it lots of different things, but it's called scrubbing the data, normalizing the data. What you have to, one of the very first things you have to do is you have to take the two values of the two sensors that are measuring your data points, and you got to get the values lined up on the same timestamps. Okay, that's normalization. Part of the reason, and the reason why is because when I see value A, when I see value A on sensor A, it may be that timestamp may be 9/100ths of a second different than on sensor B, value A of sensor B, right? But the next time they're collected, it may not be 9/100ths. It may be 4/100ths. Okay, and it makes the rising and falling edges of these values fuzzy, and it takes the machine learning models much longer to find the relationship between the two values because they're not on the same rising and falling edges. Okay, so one of the things that we do, and this is one of the big things that Greengrass, AWS Greengrass, is used on the edge when you're collecting like super high speed measurement data coming off of machines, is you're using AWS Greengrass when you're running this Lambda function to get all the values lined up on the same time series so that it's not fuzzy. If I were to look at them, they would be plotted on top of one another on the chart, as opposed to just a little bit left, a little lagging, a little early for a couple of data points. You want to do this normalization, right? And that's part of the reason we use a gateway. Part of the reason we use a gateway is to synchronize time. That's one of the reasons that we don't, and that's part of the reason we use a unified namespace as well, right? It's the exact same reason, because we want to get that data cleaned up. Now, the historian cares about the true rising and falling edge. But for machine learning and for data, any type of data analysis or reporting, you really want those things to be lined up. And a really good example is when I'm writing a report, and my report is a expense and revenue report. Okay, I will do an expense and a revenue report for January 11th, and I'll have two values. I'll have what were my total expenses that day, and what's the total revenue. But if I had run that report during the day, I may have had expenses going out and revenue coming in at different times during the day. Okay. And so if I ran my report, if what I did was I said, show me revenue and expense for every second of the day, that's going to be a really fuzzy, loud report. It's going to be very difficult for me to do any type of analysis on that. So what I really want to do is aggregate it on a specific day. And that's really what normalization is. Normalization of data is, for every value that changed over the last second, let's normalize it and get its timestamp on the second. Or let's say we're collecting every 5 seconds. Let's get all of the timestamps lined up for that 5-second group. This is the value we're going to use for that 5-second group. And I think Flow software calls it, they have a term for it too. They call it something different. But Flow software does the exact same thing. They call it buckets. They create a bucket of time, and they have a value in each bucket of time. OEE does the same thing. So hopefully I answered that question he asked about time synchronization. When you were, think about in terms of unified namespace, we don't care about the real time that the value changed. And by the way, the value that we get isn't the real time. The sensor has latency, right? The PLC has latency, right? So I wanted to talk about RTOS and, why you want to use a PLC for automation. I'm not going to do that. All right. So anyway, the point I want to talk about, there was a bunch of questions came in. Hey, what's the difference between UNS Gateway and Highbyte? There's a lot of difference. They work together. UNS Gateway serves just a very specific functionality, and that's the gateway that we're going to turn over to the community. We want to turn it over to the community and have them do something.
A couple people did ask in the Discord what happened to the logo. Do you want to touch on that, or do you want to just move on?
No, I want to touch on it. So we're doing we never planned to do anything with this, so it was just a thing we used internally. By the way, it decreased our integration time. I think we started dropping something like 160 hours, engineering hours, from every project because we're using this tool. So, I mean, it plays a huge role. It makes you much more competitive in your bids if you're not having to go in and do all that stuff from the edge. Like every integration, you're having to make new connections and all that stuff. So here's what happened. There was no name for this, and there was no logo or anything like that. So we decided to call it the UNS Gateway. And then we had a contractor who was putting together a logo for us, and they submitted the logo to us. And like the morning that we put it in the Discord, it came in, and Zach published it to the Discord, which wasn't supposed to happen. We hadn't reviewed it. We didn't do any due diligence. We didn't look to see if anyone had that logo. And it turned out that logo that we posted looks a lot like the logo for the Highbyte Intelligence Hub. It was basically the same logo, except they have like a red dot in the center. Now, I don't know if we would have caught it, because I think right now, if I asked you guys what is Highbyte's Intelligence Hub's logo, you're not going to be able to tell me, because the only place you can really see it is like when you do the install, or also when you go to the web server, it'll show up in the tab. But we didn't know it was the same. So we dropped it once we realized we were using a logo that looked a lot like theirs.
I felt really bad because I didn't know either. And then we didn't want there to be any confusion, because Highbyte has been such a large player in our community, and we want nothing but to support Highbyte. They've been really active in the Discord. Shout out to Omar. And
What's up, Robbie?
That's why we just wanted to bring that up.
How's it going, Andrew? Good to see you, man. And Michael, Dr.
Oh,
Dowdell.
I actually have a quick shout out, community
a
recognition. This is huge, actually. Can I share?
Well, who's the shout out? Let me put it in my list.
Jatin, Jatin.
Okay.
You had a post on LinkedIn I want to share. Okay, so Jatin and I, we connect with a lot of people from the community here, and over time we build relationships. And so Jatin actually, I was going to show this one here first.
Nice.
We had connected back in February. Hey, thanks for creating such a great content on the YouTube channel. And we had been connected. He had been looking for a internship, so wanted to give him a shout out. He actually did just get an internship with Tesla, and so that's really exciting. I mean, this post went pretty viral. But
congratulations, dude!
He actually did get an internship with Tesla, so I wanted to give him.
So
a shout out.
that Model S, that model. Once you if you do a deep dive on the Model S line, if you've been watching our content, everything should be very familiar, because that's what's under the hood. There is a unified namespace extending out to MES. All right, cool, very cool. Congratulations, Jonathan. All right, let's get to our questions. So Dan 24B. This was in, I think, Unified Namespace. So this is a good question. So he said, hey, all, I'm working in a water utility developing OT digital IIoT strategy. All the videos and content's great. It's really helped expand my views. One thing I'd like to understand is what people see as the differences and similarities between the Unified Namespace when applied to a manufacturing or a utility environment. The answer to that question is it's exactly the same. You can use ISA 95 in utility. So whether you're electrical or solar or whatever, water, wastewater, you name it, it's going to be the same. The ISA 95 organizational structure is the same. In an asset-rich environment where you have many thousands of assets spread out over thousands of square miles, does the UNS approach still work? The answer is, does it still work? In fact, I would argue the only way that you can effectively integrate in that type of situation is using the unified namespace. And in fact, when we originally developed the concept in 2013, it was on I'm going to go over the project that we did this on. I'm going to actually draw out what the architecture looked like and how this whole thing worked. Okay. But I would argue that you really can't do it without a unified namespace. It's not going to scale. We also have other enterprise systems such as GIS that have not been mentioned yet. Is the UNS suitable to manage the data produced by such systems? The answer is absolutely. Even your fleet management software will be integrated in UNS. And I'm going to show you, we do many integrations using ArcGIS into the unified namespace. I'm going to show you an example that we did. There was 2 examples back to back that we did, where this is one of the reasons we created the unified namespace. So for those of you that don't know what ArcGIS is, it's a geographical information services platform developed by Esri. Okay, and actually we used to have an office in the same building with Esri, but we used to have a GIS developer on our team, and she was an ArcGIS guru and like knew the API really, really well. But here was the use case where we really started getting steered towards, man, we have to do the unified namespace. We know that it's going to be right, but we have to use it. And here was the use case. I've got ArcGIS, which is basically geographical information services for, let me go to this, ArcGIS, hold on a second. All right, ArcGIS creates maps that look something like this. Okay, this is an ArcGIS map. This is an ArcGIS map. This is an ArcGIS map. All right. In a nutshell, ArcGIS allows you to create many layers of data that you can stack on top of the same map image. All right. And it's super fast. And there's a tool called ArcMap, where you can create web applications for that use the layers, the maps that are developed inside of ArcGIS. So to answer your question, the original use case was, oh man, we've got all these awesome maps inside of ArcGIS. And what I really want to do is I want to take the maps that are already there. I want to put them on a screen. And then I want you guys to I want you to use process data. And I want you to overlay alarm state over top of our maps. So I want to be able to look at a map that's in ArcGIS, and I want to create quadrants. So what you're seeing here, this is a little blurry when I stretch it out, but this is an example in West Texas. All right, you're looking at an ArcGIS map that is inside of a unified SCADA system that's built on top of a unified namespace. Okay, so what I've got here, these little boxes that you see here, that's
like the Midland Odessa area.
This is Midland Odessa, and those are assets. Those are they're not assets. They are leases lease areas sitting on top of the Midland Odessa area. This is the Permian asset. Okay, so the green outline here is the Permian asset, and then what's underneath it are all the lease areas. They're not the routes. We can actually view it by route if you want to as well. The lease operator can look and see all the areas he's responsible for. But what they wanted was they wanted to be able to go to a single ArcGIS map, the map that's in ArcGIS, and on top of the map, what they wanted to see was indications of the sites that were in alarm. Okay, so I want to see just the ones that have high tank levels, right? So what that looks like is, in your SCADA system, this is what a tank battery looks like in the system that we built. If I just went into the SCADA system and I just wanted to look at tank levels, I would have to go to each of the individual assets and look at the tank levels. What they wanted was like a level 3 screen where the operator could go to this screen and start out by looking at just the areas that have high tank levels. And then they wanted to be able to click on the map. And then from that map, from the alarm that they saw on the map, they wanted to be able to drill down to the tank battery. Now, people have been doing this for a long time. They haven't been combining it with ArcGIS, but they've been basically copying the ArcGIS map inside of the SCADA system, either taking a screenshot, and then they would create little alarms on there. It was all discrete development. It was all, if I wanted to do that, it was going to cost me a shit ton of money because I have to have an engineer sit there for weeks when you've got, a gazillion assets. So here was the use case. Everything that you're looking at here is from this big project that, we did in 2013. So here are some of the stats. This project covered 5 states. Okay. It had 14,000 sites. It had 40,000 devices. So PLCs, PLCs, pump off controllers, flow meters, and LAC units. Right, LAC units of the sales. Oh, hold on a second. 40,000 devices. They had 2,000 users. We had 11 million tags. Okay, that is 11 million values that changed in the system, and we did 2 million. We did 2 million alarms per day. Okay. Now, so when we did this project, the goal was to create an enterprise class system. That is, if I added a new well. So one of the things is that in oil and gas, this is, oil and gas funds most of this stuff because they have the money to do it. And then you take what you've developed in oil and gas and you make it work in utilities where they don't have the money, right? Or solar where they don't have the money, or discrete manufacturing. That's exactly what we did. We proved out the unified namespace concept using oil and gas customers because, when oil prices are high, they've got more money than, they burn money. I mean, so we developed it using oil and gas, and then we took that and we started applying it into discrete manufacturing. And, over the last 6 years, 5 or 6 years, it's been all basically discrete: food and beverage, life sciences, et cetera, et cetera. So in this project, we had to cover 5 states, 14,000 sites, 40,000 devices, 2,000 users, 11 million tags, 2 million alarms per day. Okay. So, and this is pretty much everything you needed to be able to see. Like,
and those screens right there, I want to point out that nothing on that screen you see is actually statically bound.
Nothing. It's fully dynamic. That's right. That's
through
fully dynamic.
Browsing of the namespace and through looking at the database that backs that model.
And once a device goes offline, or once a site goes offline, or let's say, I add a new tank. So I add a new tank. The whole idea was I add a tank out in the field. The whole idea was, right, we wanted that to push up to us rather than, okay, now I've got to go into my SCADA system and add a new tank on my screen. That's not how this works. Everything that you're seeing here, this screen is fully dynamic. So what it does is
it gets rebuilt.
It gets rebuilt the moment you open the window. That's right. And it gets built from the unified namespace. So what happens is this window looks at the unified namespace and sees the objects that are there, and then it rebuilds itself. For example, if I don't have an oil meter on this site, the oil meter doesn't show up on the window. All right. So if I just go to a different tank battery facility, what happens is this window looks to see what's there in the unified namespace, and then it regenerates itself. Okay. So if I add an oil meter, now the oil meter will show up the next time I refresh the screen. Right. That's how it scales. So when you're asking, does this scale? When we did this project, covering 5 states, so Oklahoma, New Mexico, Texas, Louisiana, and Colorado, 14,000 sites. We didn't even go to any of these sites. There were 19 developers that worked on this. We did the first phase in 18 months. The customer spent $1.6 million, including the licensing, which I think was like $500,000. So they spent $1.1 million on engineering for 1 whole year. We had 19 developers, at any given time. It was, most of the time we had 4 engineers. The vast majority of our work was building the back end. This was the first time we were ever doing it. We did all of this using Ignition. Okay. And I'm going to show you guys the architecture here in a second. It should help with the unified namespace concept, right? Because he's talking about the utility question. Let me go back to his original question. Such as GIS that haven't been mentioned yet. Is the UNI suitable? Yes, it is. One of the biggest challenges we face is aligning data from different systems that all references the same assets. So there's a couple of tricks to do that, right? And what he means here is when I create a site inside of ArcGIS, the master data model inside of ArcGIS has a unique ID for that site. Let's say I'm looking at a tank battery, and that tank battery's got a lease name, and And, it could be anything. This could be a remote water wastewater facility. In Southern California, they're all over the place, right? So it could be, anything. It could be power plants. It could be, wind or solar energy. Inside of ArcGIS, there is a unique asset ID for that site, but only ArcGIS uses that ID. Inside of my ERP system, I have a different ID for that asset. I've got a name of the asset, and then I've got a unique identifier. And then in the SCADA system, I will have a unique ID for that asset as well. If you're using Ignition, it's going to be the tag path, the path up to the folder that contains that asset. Let's say I want to combine that data and I want to do it the old way. I want to get the map of that site. I want to get the profitability of the site or the cost. And then I want to get all the process data. The first thing I got to do is create discrete connections between the SCADA system, ArcGIS, the SCADA system, ERP. Then what I've got to do is create a lookup table and then put a table inside the SCADA system that has SCADA system ID, and then the next column is ArcGIS ID, and then the next column is the ERP ID, right? And then I got to connect those. And then we're at all the places that I want to share that data. I have to run a query to get the ID so I can go get the stuff from ArcGIS that I want through the API, and then same thing through ERP. Eventually, you run out of money. Okay, that's what happens. Or they make a change, and then you can't manage the change. This is why we use the unified namespace. This is why we use report by exception. It's why we use edge driven. What we do is we take ArcGIS. What we do is we hit the ArcGIS API, the RESTful API, and we go query that API from our IIoT platform. The IIoT platform, whether it's Ignition, Factory Studio, WinCCOA, the list is ad nauseum. But I hit that API, hit the RESTful API, and then what I do is I convert it into my ISA 95 structure, and I publish it to. So what'll end up happening is the ArcGIS data gets published right next to the SCADA data, which gets published right next to the ERP data. We just tell the ERP where to put it. We tell ArcGIS where to put it, and the SCADA system where to put it. And they're all right next to each other. That's the approach we take, okay? One of the biggest challenges we face is aligning data from different systems that reference the same assets. And what I just laid out, what your primary challenge is you've got to have lookup tables that join all those asset IDs together. Historically, these systems have been completely separate, but now we want to bring all the data together. Knowing what asset a system is referencing is very difficult. Does the implementation of the UNS help solve this challenge? Absolutely. In fact, the whole point is that this was the first use case we proved it out on, exactly what you're describing here. From what I understand, the UNS and IIoT can work in these scenarios, but I'd like to confirm my thinking is correct. I'm arguing that you can't do what you're trying to do, especially in large organizations, without taking the UNS approach. You can do anything with enough time and enough money. What I argue is that what you want to do will change long before you ever finish it if you try to do it discreetly with point-to-point connections. Are there any good case studies or examples that demonstrate these concepts in a utility environment? I'd like to know what utility you're talking about first, and then I can answer that question. All right, question from Mario. Once you use SparkPlug-B, should all information related to an asset be configured only on the source? For example, machine ideal speed, although it's static, should it be in the asset information together with other information to make sure the sender is the single source of truth for this asset data? All right. Most people want to go in this direction. And basically what he's saying is once you've got the edge device connected to the unified namespace, right? How much should you put in that device? Okay. Now that device could be a PLC, it could be a gateway, it could be an edge SCADA system, whatever. But he's saying how much of the contextual information should you be putting on the edge? So that would be like the machine ID, that would be ideal rate, that would be it would be like contextual information that may normally be stored in the MES system or normally stored in the ERP. So the answer to your question, Mario, is in general, the stuff that we put on the edge to publish over SparkPlug-B is unique to what is on the edge. All right. So when you ask about machine ideal speed, If the machine ideal speed came from the OEM, that is, the OEM said, here is your theoretical cycle time, right? Or this is your minimum ideal cycle time. This is your maximum ideal cycle time. If the OEM is the one that delivered that information to you, then I would keep it on the edge because that's unique to the machine itself, that node. But let's say that ideal or that cycle time, that ideal cycle time is something that the process engineer is constantly tuning, or it's something that changes as a function of the product that's running on that machine. Well, that isn't a piece of data from the edge. That is that's either an MES function, that's an ERP function, that may be a function from your quality system. And I would argue it needs to live in that node, and be published from that node into the unified namespace, not through the device. Again, this is where the engineer's expertise comes in. We say this all the time. There isn't one solution for every problem. The solution you develop is going to be a function of the problem you're trying to solve. What we argue is start with building a technology stack, minimum technical requirements for all the solutions you use, and then run your knowledge, what you know, your expertise through that. There are going to be scenarios where you put ideal speed in the machine. I have never done it. I don't know if Ray is on the call. I'd like to ask if, Ray's doing a big project right now, one of our guys. I don't know if he's putting ideal speed on the edge. I've never put that on the edge. It's always a function of the either the CMMS or the ERP namespace in the unified namespace. All right, Denton, in your experience, how well does the ISA 95 maintenance model, so request, work order, response objects, benefit the OEE calculation for the equipment set? What application are you using to calculate OEE value, or where are you calculating it? Okay, so the ISA 95 maintenance model is not used in our experience to calculate OEE in any way, shape, or form. What it is used is to calculate mean time to repair and mean time between failure. We'll end up with two numbers. We'll have mean time to repair, which is a number. So for those of you who don't know those numbers, so mean time between failure is a calculation generally in minutes or seconds that tells you what is the average amount of time that this machine runs before it has a downtime event. So, and it's normally calculated like by production run, and then it's calculated by the shift, and then it's calculated by the week, and then the month, and then the year, and then you can group it in the area. But basically it's how long does the machine continuously run between failures? That's really what it means. Okay. And then mean time to repair is once it has a failure, once it's in a downtime reason, how long does it normally stay there? So when I have a failure, how long is it normally in failure? We normally calculate that twice, both of those numbers, mean time between failure, mean time to repair. The first time we calculate it is in the OEE engine, which almost always runs at the plant level. It lives in our case, it always lives in the IIoT platform. That calculation is being done in the IIoT platform or as a stored procedure running in the database behind it. We have a couple of different examples. Sometimes we run it in Python. Sometimes, we have a couple of different engines we use. If you use like Sepasoft's MES modules, it's going to be calculated inside of Sepasoft's modules. If you're going to use Traxys is the one that's going to do the calculation. But we will calculate mean time to repair and mean time between failure in the OEE engine, only using data from the machines. So that is, I have a downtime event. My machine is stopped, and then my machine started. Those events that come just from the machine. We also calculate it in the CMMS using the rising. So then there's another set of data, and that is when I have a downtime event, what's the average amount of time between the machine breaking and the operator opening a work order to have it repaired, which is what he's talking about in the ISA 95 model. We generally do this with Infor EAM. So that's the most common one, is Infor EAM, where we'll have the operator open the breakdown work order from the IIoT platform. So from the SCADA interface. So I have a downtime event or an MES interface. The downtime event, the operator decides whether it's something he can fix. I can't fix it. Create work order from the single pane of glass. And now what we've done is we've captured the time between the downtime event and when the operator opened the work order. We also start a timer that creates the work order in the CMMS. And now we create a timer where how long will it take the maintenance person to get the work order and show up at the machine. So then you got that rising event. And now he checks in when he gets to the machine, and we've captured that piece of data. And then now we're in repair. And then as he's repairing, when the repair is complete, he closes out the work order all from the same single pane of glass. And we've captured those 4 time events. And now we do a second calculation of mean time between failure and mean time to repair that is separate from the OEE calculation. So to answer your question, how well does the ISA 95 maintenance model benefit the OEE calculation? It really doesn't benefit the OEE calculation itself. OEE, the only thing you need to calculate OEE, what are the raw events you need? You need an in-feed count. That is what raw materials went in. Most of the time you abstract that data. Normally that is what, how much waste did I produce and how many finished goods did I produce, add those two together, and that gives me my in-feed count. You need your waste count, how much waste you produced, and then how many good parts you produced. You need those 3 counts. And then you need state. What is the state the machine is in right now? So that is it running? Is it in a running event? Is it in a downtime event? Or is it in a scheduled downtime event, a planned downtime event, they call it in the OEE calculation? If you have those 7 pieces of data, then you have everything you need to calculate OEE. That's all you need. You don't need anything from like maintenance. What you need is the information from the machine itself. Once you have those things, you can do all your OEE calculation. So one of the things I want to do, because I don't think we've ever really done this, I want to talk about, I've said this many times, but I want to go over.
I think what Denton is.
Yeah, let me finish this and then we'll go back to it. Okay. So what is OEE used for? Okay. So I'm showing you the actual workflow and ignore the exact numbers. But let's say I'm the chief executive officer of a company and I want to know what my capacity is. Okay. So let's say I've got 100 plants, and with my 100 plants, I can produce one, or I have 3 plants and I can produce 1 million units per day between my 3 plants combined. What I want to know is how many units am I producing? All right. Or how many, if I know that that's my capacity, what most people will do is they'll try to calculate a production efficiency number. And that production efficiency is based, let's say I produced on any given day, I produced 750,000. Their production efficiency number would be 75%. Okay. Now,
is that similar to TEEP?
No, TEEP is based on a 24-hour, 7-day schedule. So this capacity number is based on my operating hours.
Got it.
TEEP is based on not just operating hours, but the hours I have available in a week. So you have to use the TEEP number to determine, well, what if I went to 24 hours a day, 7 days a week, right? Okay. That's your TEEP number.
I thought you posited this scenario as if 1 million was running 24 hours, which would then in case be TEEP.
Correct. That would be TEEP. Right. So, so they normally do this type of thing. That the truth is this really isn't helpful because it doesn't get to root cause. So this is why we use OEE. So what we do is we show the OEE number at each layer of the ISA 95 stack. Now you'll notice I left out the cell, and I just did it just to make the screen not look busy, but you got enterprise, site, area line, cell. So the CEO looks at this, enterprise, or the chief operating officer, and he sees, holy shit, our overall equipment effectiveness is 50%. Now these numbers aren't exact calculations. Just if it's not a 100, know that it's less than 100. I'm just using 50 in every place. So the next thing that he'll do is he'll look at all of the plants that we have, and he sees that we have 2 of them operating at 100% OEE, which by the way never happens, and 1 that's operating at 50. That'll give me my 50%. Okay. So what he does is he then calls the plant manager, and the plant manager looks at his OEE, which is 50%, and he goes down and he looks at his areas. Okay. And he says, I've got 2 areas that are operating at 100% and one that's operating at 50%. So then he calls that supervisor and he says, supervisor, you got your area is operating at 50%. So that supervisor goes and he looks at the 4 machines he's got in his area. He's got 3 operating at 100%. He's got 1 operating at 50. And then what he does is he decides who he's going to yell at. So he looks and he sees that his availability number is 50%, his quality number is 100%, and his performance number is 100%. Okay? So what he does is he calls his maintenance manager, and he tells the maintenance manager, hey, on this machine, we've got 50% availability. What the fuck's wrong? And the maintenance manager goes into the MES system and he looks at all the individual events and he says, oh, we had 128 minutes of slow valve open. Okay. So that is a flow control valve is supposed to open in 1 second. And we got a timer running in there. And we see that it's taking 4 or 5 seconds to open every time it opens. That means we got some issue with the valve. Let's go take a look. That is a highly simplistic view of what OEE does. But here's the point. These numbers, right? You have a OEE calculation at this level. You got an OEE calculation at this level. You got one here, and you got your AQP down here. You got a OEE calculation here. What you want to do is that number, the OEE calculation, the overall equipment effectiveness number, oftentimes in like machine learning and data analytics is used as a trigger. If OEE is greater than what our target is, then let's not do any analysis. Let's focus on the things where we're under our targets. Okay. By the way, what I'm showing here is not, you would never see if you see 100% OEE, there's something wrong. I've never seen it. If you have 85% OEE, you're kicking ass and taking names. That's like a world-class number. Okay. Most of the time when we deploy an MES system, you're operating at 20, 30% OEE nearly all the time. I think the highest number we've ever seen is like in the upper 40s, 47, 48%. And then we get you into the 70s and 80s. That's a huge gain in capacity. That right there is your workflow for MES and OEE right there. What was it Denton said there?
Oh, what I'm thinking so what Denton is saying, or what you're saying, so the mean time between failure and the mean time between response, mean time for response, mean time to repair, tracking those numbers and then improving them could reduce downtime. So it could indirectly improve OEE, I think is what Denton is saying.
So mean time between failure and mean time to repair is totally a function of how quickly we fix things. Now, mean time to repair, you're going to have downtime events where there's no human intervention, right? I may have a downtime event where there's no human intervention. And so there's nothing I can do with the mean time to repair, right? I mean, normally you're focusing on, with mean time to repair, how quickly can we get our equipment back up and running? And mean time between failure is how reliable is the equipment when it is running. That is, mean time between failure is the number in minutes between failures. Now, in mean time between failure and mean time to repair really help you drill down on this analysis. And here's why OEE is important. Hold on. We have never done an MES system. We have never deployed OEE, and I challenge anybody else here who does the same thing we do. Have you ever done an OEE implementation or MES implementation when the customer wasn't shocked at one of the numbers you showed them, or where the client was not shocked by what the data and information revealed to them? I mean, every time I've ever done one, they've been blown away. Wait, hold on a second. Love the supervisor's blunt style of language. Perfect. Many were scared. Yeah, right there. Dowdell said many were scared. He's right. One of the first things that people say when you show them the real numbers, you're tracking actual digital events. You're not having human beings fill out spreadsheets and stuff, because they're pencil whipping it. We call it massaging the data. If you have operations manually tracking these calculations or these events so that you can do your calculation, rest assured they are massaging those numbers. And you want to know the number. You want to know the number one way they massage it? what they'll do is they'll increase the amount of planned downtime. So they'll like throw a safety meeting in there, which they don't get dinged for. And so that reduces the total number of available minutes to run, right? And which artificially increases the performance number. The part of when you collect the information digitally, when you correct the information digitally, they cannot massage the data. And they're always shocked. They are always shocked. And the number one thing you will hear is, that can't be right. Your calculation can't be right. You have to be prepared to prove it. And when you collect the data from the machine, look, the machine was off here. It came back on here. A person didn't tell us that. We watched it, you know. Now love the supervisor's one style. Chris. Okay. Hey, Chris. Yeah, thank you for chiming in. Chris Gill said Dan 24B is probably referring to a utility water utility. We are actually doing a case study right now. We're doing 2 case studies for 2021 from projects that we've done over the last 2 years. One is a food and beverage case study, which is a full digital transformation. If you guys are in mentorship or digital mastermind, you have already seen the project because we've demoed it for you. But we're doing a case study that shows everything in detail. The other one that we're doing is a wastewater. It's a wastewater utility. So it is a mobile wastewater utility. We did shoot a video on this, which was what was the name of the video, Zach?
That was the Lightboard video, and it was the Industry 3.0 to Industry 4.0 example, side by side.
Yeah, we were comparing like a Industry 3.0 hybrid oil and gas project we had to do with a pure Industry 4.0 project. The case study we are doing is the Industry 4.0 example, and that is a wastewater utility using Unified Namespace. In fact, ArcGIS is in there. Their fleet management software is in the Unified Namespace. So we're doing those case studies. We were in our staff meeting this week. We will go over, hey, when are we going to start the case study? So I expect the case studies to be completed sometimes in the second quarter. How about repair parts availability? Will this affect OEE? Okay, so this is a good question. This is a really good question. So that's from DW
Dwayne.
Stan 1 Texas. Which guy is that?
That's Dwayne.
Dwayne, right. So thanks, Dwayne. I cannot remember everybody's handles. All right, repair parts availability. How does this affect OEE? All right, so it depends. The answer to that question is, that depends on who you ask. All right, so the actual question he's asking is, let me, how does repair parts availability? So for example, the machine breaks down, the machine breaks down, and I don't have parts to repair it. How does this affect OEE? Here's how it's supposed to affect OEE, but this is not the way they generally do it. It is supposed to ding the availability of the machine. Okay. So that means that machine should just stay in downtime, and you should end up with like an OEE number of like, let's say it takes 3 weeks for the part to come in. Its OEE number should be like 0.000001. Okay. And if you looked at the availability number, it should be like 0.000001. That's the way it's supposed to go. Okay. Well, what ends up happening, there becomes a holy war in the organization. What's important is it drives a conversation. The maintenance manager who's being held accountable for the availability number, that maintenance manager is going to start having a conversation with procurement. He's going to start looking at the CMMS. What are our replenishment numbers? And there will be questions that come up as to why was that part not available? Okay. The point is that number it should negatively impact the availability number. But in most cases, what they end up doing is they remove that machine from the schedule. So
why would they do that though?
So that
Just
nobody
to make
gets
a better
dinged.
OEE.
It indicates there's a problem. Yeah, they're massaging it. In most cases, they'll remove that machine from the schedule so that nobody gets dinged for it. Okay, nobody gets dinged for it. And the only place that it would show up is on the TEEP number. So if you're comparing TEEP and OEE, you would see it would get baked into the TEEP number because that asset you can't get rid of in the TEEP number.
Because now you're hurting you're scheduling less time to produce.
Correct. You're scheduling less, which means you're Your OEE number stays high, but the TEEP number comes down.
Right. I mean, you want to know these numbers because at the end of the day, you're not making as much money.
Dwayne said, agreed. Accuracy to the real world is high. That's how I know Walker knows this stuff. Oh, I'm using the examples of, I'm using the examples that everybody can relate to. I want to use, I was going to use an example here. Hold on a second. It'll come up. Let me go over to YouTube real quick. I got to finish a couple of questions on YouTube. All right. So JRS89 said, do you have a link to this intrinsic versus extrinsic white paper? No, but we'll add one. Please put that to our action items. I feel like this could be applied to the, so for those of you, if you didn't watch the intrinsic versus extrinsic motivated engineers, I'm using extrinsic and intrinsic motivation as being analogous to Industry 4.0 versus Industry 3.0 companies, right? You basically, being an intrinsically motivated organization is one that innovates even when people are sleeping. Why? Because you've automated the process of innovation, and you've done that leveraging IIoT, Industry 4.0, and digital transformation. Examples of companies like this are, Tesla is an example of companies like this, okay? Mario, that would be done in the ERP and used in planning. All right, well, Mario said, should lines have a weight of importance when calculating the area OEE? If line A creates a product that is 10 times more valuable than line B, should their OEE have similar importance in the area? So Dowdell is exactly right. And so Dowdell says that would be done in the ERP and used in planning. He's correct. It's done on the planning side. However, so Mario, to answer your question, at the operations level, no, there shouldn't be a weight. When I'm looking at the area OEE number, what I really care about is we don't apply a weight to more valuable equipment when we're calculating OEE, but we do when we are planning to produce. When we are scheduling, we do. Dwayne, the wastewater project, we just started doing the case study. So I have a meeting with Matt, the engineer who did it, who's doing the finishing the case study. We'll go over it. I don't expect the final case study to be done until probably right at the beginning of the second quarter. So maybe April we'll have it for everybody. Because we're doing two of them at the same time. But yes, Dowdell's exactly right. It's done at the planning level. You basically plan your most valuable equipment first. That's generally the approach you do. I want to finish JRS's question. They're overly focused on the day-to-day operations at the expense of innovation. Some people feel compelled, rewarded, and motivated to put out fires. While they're not lazy, they're not being as productive as they could. While some organizations find time to pivot to innovation, they struggle to sustain and maintain it. These are the plateaus that create gaps between competing firms. Exactly. Here's one of the biggest things that you will notice. If you're doing digital transformation or you're meeting with lots of different companies, I think last year alone, I met with over 100 different companies. Most of them, like 70% of them were, billion-dollar companies and above. And one of the first things you notice is that the most innovative companies in the world all have one thing in common, and that is super strong leadership. And because they have super strong leadership, everyone in the organization knows what their digital strategy is. If you ask them, and I ask this question all the time, what is your digital strategy? And if you hear crickets, it means one of two things. Either they don't have a digital strategy yet, or they have poor leadership. And that's a question you need to know. You need to know, does this company have poor leadership? I cannot tell you how many boards I've gone in front of and walked out and told my team, holy shit, there's nobody on that board who has any idea what they're doing when it comes to digital trans. I mean, no idea. They have no idea how it's going to benefit their organization. They have no idea. Like they read some McKinsey white paper. They don't know what it means. And they don't have any idea at all. And That is the predominant state of manufacturing in the U.S. Phil Scruggs, good discussion on motivations. Didn't Elon Musk in interviews from 2018 mention that he had too many robots? Yes, he had too many robots replacing human beings, but don't conflate robots with automation. Robots are a subset of automation. So if many robots are not the answer, that doesn't mean that automation is not the answer. Building things that people should be involved with. Correct. There seems to be a fine balance between deciding when to implement the latest innovations over traditional methodology. Here's the most important thing in automation. Okay. Or most important thing in manufacturing. To continuously improve your process, your engineers need to be very close to that process, and they need to have a complete understanding of how that process operates, both on a theoretical and practical level. Digital transformation is what collects all of the practical data that they need to analyze. Then you need to have your process engineers and your machine builders close to the process to improve. There is a great article in Forbes from like 6 years ago related to General Electric and how General Electric designed 15 years ago, they designed, I think it was a washing machine, or it could have been a dishwasher, but they designed a washing machine.
Water heater.
It was a water heater. Right. And we did a video on it, and they designed it in the United States, like in Indiana. They designed it, they built the machines, all that stuff. They shipped it to China. And for 15 years, they manufactured that line. They wanted to make some changes. So they brought the line back to Indiana, and they wanted to get, I think it was like an $1,800 water heater. And they wanted to make the machine builds less expensive or whatever. And they wanted to change a couple of the parts. And what they realized was they actually got the cost of that water heater down to like $700 or something. And it was simply because the engineers who worked on the production lines had not had a chance they were only going to China twice a year. And most of the time they were in a hurry and jet lagged. And so they weren't ever doing deep dives on the equipment. And just by being close to the equipment, they were able to improve the process to the point where they got the cost of their cost down by 50%, which dropped the cost to the consumer down. And so there was this whole movement. Oh, wait, let's bring everything back stateside and let's have our engineers improve all the processes. Where digital transformation comes in is this whole idea that we're going to want to automate that innovation. So we want to be collecting that. We don't want to have to make a discrete decision to innovate. We want to be innovating even when we're sleeping. And then we decide whether we want to execute on that innovation, right? That's the component of the Holy Grail. All right. JRS said, yes, some of the assembly was overly automated. On one hand, it was not economical. It actually impeded productivity, hurt product quality, increased manufacturing costs. On the other hand, there's something to be said for pushing the envelope and proving where the limits are. By knowing the limits and understanding why, it makes it easier to innovate down the road. I'm sure Tesla, Fanuc, and their integrators have tons of lessons learned. Yes, when I talk about Tesla, I'm speaking firsthand knowledge. Now, we were just talking about the engineer I worked on who I worked with on the Tesla project, he was doing all the PLC code under the hood, and I was doing all the front end piece and the architecture. Yes, Tesla tried to over automate. The things that we talk about automating are, think of all the overly manual processes where people are exposed to injury, repeat injuries. So where they're doing a task over and over and over and over again. Those are the types of things you automate out. And then you take that position and you that spot and you move them to another spot where it's not automated yet. And through attrition, that person leaves. And the way you gain is you take the money you're saving from a couple of positions you've automated. And now what you're doing is you're putting, data scientists on your team, operations analysts, that kind of stuff at an higher level. If you look at the most advanced facilities, like the dark facilities that we talk about, instead of having 3 operators on every production line, what you've got is 1 operator running 3 lines from a control room, at a desk, and the production environment's dark. And the only time they turn the lights on is when they're going out to do continuous improvement or they're going to fix something. But that team, that group of 3 production lines has, an operator. It may have 2 operators, may have a material handler. And then you've got a process engineer who's dedicated to just those 3 lines. You got a continuous improvement engineer, a quality engineer. what you end up seeing is you're taking this team of higher paid people, higher paid professionals, and spreading them out across lines, but through automation. Everyone who says that automation takes away jobs is correct in a sense. That is it. We automate out all the right jobs, the stuff that's going to get people hurt, the stuff that has really high turnover, the stuff where all I'm really doing is asking someone to use their muscles over and over and over and over again. But what it does, it creates net jobs. And I mean, we've proven this out over and over and over and over again. Automation and digital transformation, it has a net gain in jobs, not a net loss. I mean, it's just anyone who's saying otherwise just is not looking at the data. I mean, all you got to do is go to the Bureau of Labor Statistics to see. All right, is ThingworX a unified namespace platform? No, but it connects to it. It can connect to a unified namespace. Can you discuss where Kafka fits into IIoT? I understand the UNS can be fed into Kafka, but I see some overlapping functionality. Yeah, so here's the way we use Kafka generally. Kafka generally has a copy of the unified namespace sitting at it. One of the things that's really important to understand is the UNS doesn't live in one place. It's omnipresent. Okay, you can create many copies of the UNS and create like this whole infrastructure. And I mean instances. I can have a broker running on my laptop that is an exact copy of the master broker. Okay, I can create like this tiered hierarchy of my unified namespace, right? Where I've got a distributed unified namespace in one business unit, and everybody who's under the business unit is just making copies of the unified namespace from just the business unit all over the business unit on my laptop, on that server, and basically through this architecture, distributed architecture, copies of the broker are everywhere. It's the same thing with Kafka. We create a copy of the UNS at Kafka, and what happens is Kafka will report if I'm doing analysis, for example, in Kafka, it's reporting that data into the unified namespace. Most of the time, what we're doing with Kafka is we are taking time series events through the unified namespace and dumping them into Kafka and allowing people to do analysis through that interface. Okay. Jeremy McCabe. I don't have any degrees, but when I became a supervisor in automotive production, I did just what you said. This is, what do I have to study to be a system integrator? Jeremy, thanks for pointing it out. We do not, I don't care about degrees. In fact, I don't know if I've ever told you guys this before, but I don't read resumes when I interview people, and I don't look at your resume until after we've decided to hire you. So, and I encourage our team to not look at your resume until we've made the decision whether we want you on the team. Your degree doesn't mean anything to me. I could give a shit. All the best engineers I've ever worked with, don't have degrees in engineering. The best software developers, I mean, hell, the greatest software developer I've ever worked with has a degree in medieval literature. Okay, so the degree is important. I'm not telling you don't get an education. It's important. I'm making my kids all get college degrees, but it's a hoop you jump through. What the degree tells me is that you can start something and you can finish something. That's what the degree tells me. The people I really like are the people who went to like 6 different universities, changed their major 5 times, and took them 12 years to get a 2-year degree. I like those people. You know why? Because they're agile. They're agile by default. They ran into problems. They figured out a way to solve it. They learned something about themselves and pivoted, learned something about themselves and pivoted, learned something about themselves and pivoted. I like those people the most, to be honest with you. Now, granted, I took my education very seriously, and I have multiple degrees with an advanced degree, and I went back and got a degree in engineering. I did those things because if I was going to be if I wanted to take it seriously, the degree was important. But he thought of the things they could use, and he made it himself. He's a tinkerer. That's what this guy is. What I refer to this Jeremy McCabe is a guy who snatches victory from the jaws of defeat. Sam Kirby, on the OEE series coming up, maybe touch upon, is it OEE that the end user really wants, or is it a machine production utilization display? which can be scaled into true OEE over time after adding the infrastructure and architecture to do so, giving multiple cost options and tangible benefits off the bat. Regards, Sam. The answer is yeah. They care about machine and production utilization at certain layers. The reason we talk about OEE, here's the most important thing about OEE. If done correctly, and Dowdell and those guys will back me up here. If OEE is done correctly, what I can do is I can take processes that are totally unlike, and I can compare them to one another. I can take a batch process, and I can take a linear subassembly process, and I can compare them to one another. If I know how much it costs to operate that one and how much it costs to operate this one, I take that OEE number. The OEE number is the one number that allows me to compare them apples to apples if you execute the collection of the data correctly, right? You're using the correct in-feed count and you're capturing state correctly and that kind of stuff. All right, cool. Any other questions? I'm 16 minutes over. Yes, hold on a second. Dowdell, does EMQ create self-replicating broker? My objective is to create copies without creating another connection from the edge or some other node. The answer is self-replicating. That's a good question. I didn't look to see. So EMQ is the broker that we use. It's an enterprise class broker. We use HiveMQ as well, but we like EMQ because the pricing is a lot clearer. I don't know if it's self-replicating. The way that we do the replication is we create a new broker instance and we subscribe to the full namespace. That's how we do it. And so we start with an original, but with the enterprise, what we end up having is redundancy built in. Zach Wooten, SC, South Carolina, I'm assuming. Elon's 2018 comment. Automation is like cooking, one plate at a time with a few pans. Trying to cook tomorrow night's service today in one batch equals poor quality. Elon meant too much at the wrong time. Correct. Spot on. One of the biggest things that you noticed in what that Tesla went through in the beginning was they tried to use the typical automotive model using tier 3, tier 2, tier 1 suppliers, and they learned a bunch of things. What he originally thought was, we're going to use the existing model and we're just going to become the most automated manufacturer on the planet, and the way that we're going to change is we're not going to update our models every year. We're going to update the software. That was like his original vision. What he did was he created a completely different supply chain for automotive, because he realized, wait a minute, these automotive suppliers create junk. I mean, I have some great stories about like projects we've done for tier 1 suppliers, Dowdell, even in Mexico, actually, where we were working on a project where they were creating a wiring harness for a transmission that was a shared venture between two of the big three, and in all the data collection. So the two companies they require that you calculate OEE, and they'll write it into the spec, right? Everything was pencil whipped. I mean, it was crazy, like how poor of a job they were doing making this wiring harness for this transmission. It was terrible. I mean, terrible. And we would comment, the engineers would comment to one another, oh my God, I'm never going to buy that vehicle ever. Like it was junk. All right, cool. I
have a question.
Yeah. Anything else I need to cover?
You want to stop sharing so we can end it out here?
Yeah, I would. Well, let me go back to my notes. And
if there's any more questions,
yeah. Yeah. Let me make sure I covered, I did white. Oh, actually, you know what? Let's go through these screens. I didn't go through all these. So this was that huge project that we did. So this is all the ArcGIS interface. Everything that you're looking at here is inside of Ignition. So these are all screens in Ignition. This is these are some pond screens. So this is where they the ponds where they did the
this is the fracking water distribution. So what they would do is
they would pull the fracking water from these ponds.
Yeah, so they were a vertically integrated oil and gas company, which meant that not only did they do the production and the drilling, but they also transmitted the water for the drilling, which was kind of crazy. And that's what that screen was showing. Oh,
I wanted to show the architecture. Damn it. I didn't do that. Hold on. So sorry guys, I want to show you the architecture. So we had 5 assets covering 5. We had 5 assets covering 5 states. Okay. So basically, the way that this worked was for each asset. That is, asset is like a business unit that produces oil and gas, but it doesn't matter what your. We had 5 of them. I'm just going to use 2 for my illustration. Here's how it worked. All of the sites were remote, like over radio networks. So I may have had asset 1, which would have been in West Texas, and asset 2 was in South Texas. Okay. Asset 1 may have had, let's say, 5,000 sites. It was the biggest one that they had, and then they had another one that had 1,000 sites. And the sites could have been oil well. It could have been a tank battery, a saltwater disposal, could have been a LAC unit, could have been a couple of things, right? And they all communicated back to the asset over radio networks, or a combination of cellular or free wave, that kind of thing. So what we did was we created a unified namespace on the edge, okay, for each asset. So we created a unified namespace on the edge for each asset. And this unified namespace only contained the sites, and it contained process data and sales data. Okay. So that's all you had on the edge. And that process data could include like alarms. Then what we did was we had a single pane of glass for the entire business. Okay. This is why they had to create the gateway area network. They didn't even call it back then the gateway area network in Ignition. They called it federated tag provider is the way it was originally. It was designed for this project. It was developed during the project. I remember Colby did it like over a weekend or something. But then what we have is the unified namespace.
But it wasn't using MQTT. I think it was using WebSockets.
WebSockets, right. It was using WebSockets. Yep. So what we did here is we created remote tag providers. So before we used MQTT here, we created remote tag providers. Inside of so you had Ignition running on the edge, and you had Ignition here. Everybody interfaced with Ignition here. The only thing that happened out on the edge was all the asset collecting everything. Okay. We had KEP server and Ignition running on the edge, and then you had Ignition running up here. We created remote tag providers that pulled all of the names, the unified namespace from this asset up into the central unified namespace. And then we added things like spot fire analysis. I'm trying to think. Yeah, XPOC. We wrote a tag provider for XPOC where we connected to XPOC and combined everything together for these assets. We did accounting. I can't remember which accounting software they used. ArcGIS. We integrated
over 100 different softwares that each one essentially would have, in theory, had to write an edge gateway to plug into the UNS.
Correct. And so then all of the users interacted with this central system right here. They all interacted with this central system. But what we did was we did load balancing by creating a unified namespace for each asset. Now, this was 2013. If we were to do this today, we would be using MQTT to do it. I didn't even meet Arlene Nipper until a year after this project was done, and we were like, and we made this work. This is the one that we did I think that was my second Firebrand award. I think I got one the year before, and then that year. But yeah, that was the architecture. So I wanted to make sure I pointed out, and so then this central unit talked to everything. I mean, this is the enterprise gateway that was based in Irving, Texas, and it talked to everything else. The only thing that this asset server was like, in Midland. Asset 1 was living in Midland, and there was a failover in like Pecos, Texas, or something. And then, the one that was in Colorado was in Colorado Springs, and they had a failover in Denver, that kind of thing. So
this is actually where Highbyte would have been useful, because
there's so many.
We could have done the modeling, which all these assets were like, they could have bought an asset from another company. So even though they were using Wonderware at both assets, the developer and the naming convention was completely different.
Yeah, this was, if we hadn't taken the unified namespace approach here, I mean, to put it in perspective, okay, let me throw this out here.
Or
This
to put it in
project,
frameworks.
yeah, this project went up against Signet at the same time. I think there were four vendors that bid it. It was Signet, Wonderware, Ignition. This was by far the biggest Ignition project at the time. It wasn't even close. When we did this project, no one thought that this was going to be possible, that you would be able to do it in Ignition. And had Kepware not developed the API, had Inductive Automation not developed the federated tag provider, I mean, we even had to like build alarm management in it. You know, Dennis is the one who did the alarm management piece. Like, most people didn't think it was even possible when we did it. When we, even to this day, when we tell the numbers, no one's like, what? You know, we discovered that it was on this project.
Named queries were
named queries. UDTs. Remember, UDTs originally used 30% more memory than flat tags, and we had the Inductive Automation had to fix that bug. Or actually, I don't think it was a bug. I think it was by design, and they refactored it.
I personally found like a half dozen bugs on UDTs.
Yeah, they got sick of talking to you about but the point was that the other projects that this went up against, okay, so you want to talk about the value of the unified namespace, open architecture. The Wonderware bid was like $25 million. The Signet bid was like $75 million. It was like these huge numbers, like these massive numbers, like just absurd numbers. If you were to try and do this, I mean, you would spend tens of millions of dollars in any other approach. And by the way, there's another integrator. So there's another, we didn't bid phase 2 of it, primarily because my engineers all said they were going to quit if we bid it. So we didn't bid the second phase of it. And so what we did was we trained another integrator to work on it, and they came behind, and now they've adopted the same technologies, right? And they've really grown in their business because they've developed the exact same development approach. So, you know, this stuff, you know, there's no OEE here, you know, this is oil and gas, but it goes back to that original question about the utilities. That's the fundamental difference. Like in utilities, utilities, oil and gas, those are 24-hour days, 7-day a week operations, and they don't look at numbers like OEE. Go ahead, Zach. You were going to ask a question. Sorry.
Oh, yeah. So I guess my final thing was, with Tesla potentially entering the HVAC and home energy market, like kind of creating their own little Tesla ecosystem with their battery, their car. What would you think about an OEE that represented an overall energy effectiveness, which could accurately represent the energy efficiency of a home, which could potentially lead Tesla further down the track of, you know, going fully renewable. If we can not only increase the production of renewables, but decrease the consumption of wasted energy using a concept like OEE, what would your thoughts be? Like, this is just ending on like a kind of an open note.
All right. So the truth is there are tinkerers out there who already do this. Okay. And I can think of one guy who I already know does this. They basically use the Google Nest API. So they use Google Nest, and what they do, and then they have a weather station, and they, you know, essentially do calculations based on what is energy consumption over time compared to certain weather conditions, right? So if the weather condition is X, Y, X, what is my energy consumption? I make modifications, and then I look at my energy consumption. Most people don't do that at that level. They'll just do it month to month. They'll look at their bill. Oh, let's replace some new windows. Oh, my bill went down $11. You know, they care about that kind of stuff. If you're using machine learning, like, you want machine learning to predict, you know, to notify you that you left a window open. You know what I mean? Hey, there's something, or your filter needs to be changed. I mean, look at when you change your filter, right? In your HVAC unit. You don't change it at the optimal time. You do exactly what manufacturers do. You set preventative maintenance time. You know what I mean? You say, oh, I'm going to change these filters every 90 days, or I'm going to change, you know, and that's what you do. Even Google Nest does that. it basically tells you, hey, time to change your filter, every 90 days or I think it's on mine, it's like every 6 months. You can do this using Google Nest already. Google Nest will give you a report on your energy usage, and you can use a smart meter in your house, which I do. I actually, my house in New York where I was, I actually have a smart flow meter.
On the
I
Zigbee.
have, what's that?
You have the Zigbee?
Yeah, no, the Census. It's called Census, but I've got the Census, I've got the Google Nest, and I have the smart electrical meter on my house. And basically, I mean, it wasn't very hard. I just Googled like, hey, how do I talk to these? And I bring them in through Raspberry Pis and Arduinos, and I'm collecting the data now. All I'm doing right now is just storing that data, every minute, and then I'll play with it and kind of see how it could work. But yes, that's coming. I mean, you're going to have an efficiency score on your home, and it's going to be, the beauty of that is something that doesn't have to be technology driven. I prefer to, but there are solution-driven solutions out there that are going to be able to do that.
And Tesla
would be
an example
Right.
of a solution-driven one, huh?
Right, absolutely. I mean, manufacturing, you can't go solution-centric. If you go solution-centric, there's always going to be equipment. There are going to always be processes. There are always going to be testing units. There are always going to be something in your facility that was made by someone other than the solution provider you selected. And then you either have to integrate it somehow manually, or you just have to leave that data out. So,
all right, guys.
All right, cool.
Thanks for joining.
Yeah, thanks everybody. Thank you for all the questions. Hopefully I got to them. If not, we'll hit them up next week.
See you guys.